Let's find out the coordinate of the incenter of a triangle. So we'll begin by considering a triangle ABC. So let the coordinates of A, B, and C be given by x1, y1, x2, y2, and x3, y3. Now in the next step, what we'll do, we'll also name the sides of the triangle. So here we'll consider the side BC, which is opposite to angle A, is going to have a length A. Then we have CA. CA is the side opposite to angle B that has a length B. And then we have the third side AB, which is the side opposite to angle C. We're going to represent it by the letter C in lowercase. Fine. Next, in order to find out the incenter of the triangle, what we'll do, we'll consider the angle bisectors of the triangle ABC. So here AD, BE, and CF, these are the angle bisectors of the triangle ABC. And we can clearly observe here that the three angle bisector meets at a common point I, and that's going to be the incenter of the triangle. So I is going to be the common meeting point, and it's going to be referred as the incenter of the triangle. So our goal will be to determine the coordinate of point I. So what we'll do, first we'll try to figure out what's the coordinate of point D. For this, we're going to consider the line AD. So AD is the bisector of angle BAC internally. Now clearly AD bisects BAC internally, so we have the ratio AB to that of AC. So that's going to be equals to the ratio BD to that of DC. Now here we have already defined the value of AB as well as the value of AC. So let's substitute those values here to get. So C over B will be equals to BD over DC. So this immediately tells us that AD is going to divide BC internally in the ratio C is to B. Fine. Now what we can do, we can find out the coordinate of D using the section formula. To find out the x coordinate, so we will take B and multiply with the x coordinate of x2, so that gives us bx2, and we add it to C times the x coordinate of C, so that's cx3, and this will be divided by B plus C. Similarly, to find out the y coordinate, we take B and multiply it to the y coordinate of B to get by2, and add it to C times the y coordinate of C, which is cy3, and divide this by B plus C. So this is going to be the coordinate of point D. Now that we have the coordinates of point D, our next goal will be to find out the coordinates of point I, the incenter. Now, in order to find out the coordinate of I, first we'll have to find out the value of BD. So here it's given here that BD is C, but we'll try to find out the value of BD in terms of the sides ABC. So let us begin. So we'll start from equation number 1, where we got that the ratio of AB to that of AC is equals to the ratio BD to that of DC. Now what we'll do, we'll take the reciprocal of these two ratios, and that's going to give us, we get AC over AB equals to DC over BD. We're going to add 1 to each of the ratios on both sides. So that's going to give us AC over AB plus 1 equals to DC over BD plus 1. So let's combine them with 1 on both sides, and we will get. Now we have the value of AC. So AC is given by, so let's note it down. AC is the length B. We have AB, which is a length of C, and BC has a length of A. We can replace AC with B and replace AB with C. And on the right hand side in the numerator, we have DC plus BD. Now clearly from the figure, if we add DC and BD, that's going to be nothing but the length BC. And since BC is A unit, so we can replace the numerator of the ratio on the right hand side with A. So let's do that, and this is going to give us, so we get B plus C over C equals to A over BD. Now what we can do, finally solve for BD, and that's going to give us, so we get a BD that will be equals to AC divided by B plus C. Now we're going to consider the angle bisector BI. So BI bisects angle ABD. Since it is bisecting angle ABD, so we get a new ratio, which is going to be AB over AD, and that ratio is going to be equals to AI over ID. Now, what we can do, we can replace the value of AB with C. We can replace the value of BD, which we have already obtained here, AC over B plus C, and that's going to give us the ratio of AI to that of ID. So let's do that as well. So we get the ratio AI to that of ID will be equals to, we have replaced the value of AB with C, and the value of BD, which we obtained as 8 AC over B plus C. So here we can factor out C from both the numerator and the denominator, and this is going to give us So we get b plus c over a. So that means the point I is in dividing the line AD in the ratio b plus c to that of a. So we have obtained a ratio in which bi is dividing AD. So now that we have this particular ratio, let's write it down. It's the ratio b plus c to that of a. We also found out the coordinate of d. Now we can use the section formula to finally obtain the coordinate of I. So here what we do, to find out the x coordinate of I, we'll start with a and then we're going to multiply with the x coordinate of a. So we get ax1. Then we take b plus c and multiply to the x coordinate of point D. So we have b plus c multiplied to the x coordinate of D. And this is going to be divided by, so we have a plus b plus c. Similarly, to find out the y coordinate, we'll start with a and multiply it to the y coordinate of a. So we get ay1. And then we take b plus c and multiply it to the y coordinate of D. To get this expression, b plus c times by2 plus cy3 over b plus c. And it will be divided by a plus b plus c. Now clearly what we can see here, we can factor out b plus c and then we can also factor out b plus c, and this is going to give us the expression, the final expression for the coordinate of point I. So we get ax1 plus bx2 plus cx3 divided by a plus b plus c, and ay1 plus by2 plus cy3 over a plus b plus c. That's going to be the y coordinate. So this is how we can define the coordinates of the incenter of a triangle ABC whose vertices have the coordinates x1, y1, x2, y2, x3, y3, and here ABC in lowercase represents the side of the triangle ABC. So this is going to be the coordinate of the incenter of a triangle. So let's try to understand this with the help of a problem. So we have a triangle whose vertices are 0, 6, 8, 12 and 8, 0. We need to determine the coordinates of the incenter of the triangle. So let's say we have a triangle ABC. We'll suppose that the coordinates of the vertex A, that's 0, 6. Coordinates of vertex B, that's let it be 8, 12. And coordinates of vertex C, let it be 8, 0. So our goal will be to find out the coordinates of the incenter. So here what we'll need the length of the sides of the triangle. So let's find out the length of each of the sides of the triangle. So here we will first try to find out the length of BC, because we're going to represent BC by the letter A in lowercase. That's the side opposite to angle A. Now how do we find out the length of BC given the coordinates of the endpoint? All we have to do is use the distance formula. So what we'll do, we'll take the square root. Underneath the square root, first we'll have to take the difference of the x coordinate, square it, and then add it to the square of the difference of the y coordinate. So to take the difference of the x coordinate, all we do is take the x coordinate of B, so that's 8, and from it subtract the x coordinate of C, so that's also 8. Then we go to the next one, which is the difference of the y coordinate. We'll start with the y coordinate of B, so that's 12, and from here subtract the y coordinate of C, so that's 0. Solving this is going to give us the length 12, so that means E comes out to be 12 units. Then we will try to find out the length of AC. So AC, we're going to denote it by the length B in lowercase, because that's the side opposite to angle B. So we'll again use the distance formula to find out its length. So first we'll need the difference of the x coordinate. So let's do 0 minus 8. So we have 0 minus 8, that's the difference of the x coordinate. We square it and then add it to. Next we need the difference of the y coordinate. So that's 6 minus 0. So we square this value. So this is going to be equals to 10. Then we have the third side AB. So AB is going to be equals to the length C. So that's the side opposite to angle C. And by using the distance formula, we have 0 minus 8 whole squared added to 6 minus 12. So that's going to be, let's write it down, 6 minus 12. So this is also going to give us a length 10. So now we have the length of each of the sides of the triangle. So we get 12, 10, 10. Fine. Now, how to find out the coordinates of the incenter? So that's a very simple task. The coordinates of the incenter I will be, so we need ax1 plus bx2 plus cx3, and this is going to be divided by a plus b plus c. Then the y coordinate is ay1 plus by2 plus cy3 divided by a plus b plus c. The way we choose ABC is extremely important here. So let's substitute the value. So here we have 12 multiplied to x1. So x1 is going to correspond to the x coordinate of A. So this will be multiplied with 0. Then added to b. So b is 10. So we have 10 times the x coordinate of B, so that's going to be x2, which is simply 10 times 8. Then we have cx3, so c, we obtain that value as 10, and this will be multiplied to x3, so x3 will correspond to the x coordinate of c, so that's 10 times 8, divided by, we need a plus b plus c, so that's 12 plus 10 plus 10. So this is the x coordinate. So now we have to find out the y coordinate, so we'll start with a times y1. So y1 will be 6, so 12 times 6 added to by2, so b, that's 10 units, multiplied to y2, that's the y coordinate of b, which is 12. Added to cy3, so c is going to be 10, multiplied to y3, so y3 is the y coordinate of c, so that's 0. Whole divided by a plus b plus c, so that's 12 plus 10 plus 10. So this is going to be the coordinate of the incenter. So let's simplify this value, and we are going to get, so we have 12 times 0, that's 0. 12 times 8, that's 80. 80 plus 80, that's going to be 160. Divided by, so 12 plus 20, that's going to be 32. Then in the numerator, for the y coordinate, we have 12 times 6, that's 72. So 72 added to 10 times 12, so that's going to be 120. So this gives us a value 192. So 192 divided by 32. So if we further simplify, this is going to give us the value. 32 times 5, that's 160, and 32 times 6, that's 192. So that means the coordinate of the incenter of the triangle with vertices 0, 6, 8, 12, and 80, that's going to be, so it's going to be somewhere here, it's going to be 5, 6.